All right, so good afternoon. I'm Philippe De Ryck, and I'm here to talk about passkeys. And the title is kind of dramatic, right? It's the future of user authentication. To be very honest, it is the future, but it's not going to be a dramatic, drastically changed future. It's going to be a gradual evolutions of how things are going, and passkeys are actually quite important in that story, and that's what I'm here to talk about today. So the real question is, what is the current state of user authentication? And if you think about that, we've been using passwords for a very long time. And everybody uses passwords, and surprisingly, everybody kind of knows how to use passwords. Maybe not securely, but they know how to use passwords. So that's definitely one part of the story. But then we try to make it more secure, right? Because a password can be reused, a password can be stolen or guessed if it's the name of your dog or something like that. And we started adding additional security features on top of passwords. We had like second factor authentication. We also have to provide a code. And then maybe a third factor to make it even more secure. And then risk-based authentication in case something seems off, like if you're logging in from Russia all of a sudden, we need some additional security checks and so on and so on. And eventually what we've been doing is we're trying to patch this inherently broken system and trying to make it more secure by adding layers on top and on top and on top. And what we've done is create a mess, basically. That's a very short conclusion of what we're doing, and I think we can do better, and that's what I'm going to talk about here today. And there's all of these stories about killing passwords and the end of the password and so on and so on. And if you look closely at a story like this, you will see that this one is from February 25, 2004. That's 20 years ago. 20 years ago, we were like, we're going to kill the password. And here we are today, and you know where we are today. We haven't killed the password. We barely made progress in killing the password. And that is the sad state of affairs that we have today. And I can keep doing this. I have more stories. This one is from 9 years later, 2013. Will passwords become obsolete soon? No, they won't, because 11 years later, we still use passwords day in, day out. And then we have the next iteration in the story is the beginning of the end of the password. Like again, we're trying to terminate passwords, and this time, I think we might be able to succeed. This time, passkeys have the ability to make things significantly better when it comes to security, and they actually have the chance to replace passwords. However, they're not going to be the password killer, as in my prediction here, which is always dangerous, especially on a recorded session. My prediction is that in 10 years, we'll still be using passwords. Maybe not everyone, and maybe it's only the less secure users and the more technical, more advanced users will be using passkeys and so on. But chances are that this will not eradicate the password fully, but it's going to be a solid replacement for those who want a more secure replacement, and will definitely help in more secure scenarios like business applications, enterprise apps, and so on. Their passkeys can play a crucial role. That's going to be the story of today. I'm going to explain to you how to use passkeys as a user. I'm going to explain to you how to use passkeys as a developer and how things fit together in your architecture. All right, in case you don't know me, I'm Philippe De Ryck. I'm from Belgium, so this is a local event for me, and I'm a security expert. So basically what I do is I help developers understand security through trainings, through courses, through sessions like this, videos, conference talks, and workshops. And I also do specialized consulting on complicated topics like OAuth, OpenID Connect, API security, and so on. I'm also the organizer of SecOpDev, which is a yearly course in Belgium running about application security, where we have speakers from all over the world to talk about application security. All right? If you want to know more about me, you can easily look it up online. But we're here to talk about passkeys, so let's talk about passkeys. What are some of the security requirements for a secure and a good user authentication system, right? That's a question that requires some introspection, because good means it's usable, right? It means it's not overly complicated so that you need like a PhD in computer science to understand how to use an authentication mechanism. That's probably not the best solution for the everyday user or even a normal technical business user. It also needs to be secure. Like it needs to be protected against common attacks like phishing, where we're trying to steal the credentials with like a fake website. That's something that should not be possible, which unfortunately is possible with a lot of mechanisms today. It should be protected against reuse, like not using the same password on all different websites. That's a massive problem we have. Shouldn't be subject to guessing attacks, brute force attacks, and so on and so on. So all of these security properties are really, really, really important. And then finally, it should be portable. Because today, authentication should be portable in the sense that you're not using a single device for all your efforts. You're using a computer and a phone and a tablet, an iPad, whatever you're doing, maybe even a watch these days that needs authentication where authentication is important. And that portability is something that has to be present in whatever you're trying to do when it comes to authentication. And that's where passkeys kind of fit in. Because if you're talking about this in a Passkeys story, it's not like passkeys are this radical new solution to authentication. Instead, they're kind of this evolution of things that already existed, have been reshaped, have been reformatted, maybe add some features to it, and eventually we ended up with what passkeys really are. But before we dive into passkeys, let's list these requirements very concretely, because we'll come back to this later to make sure that whatever we're doing actually makes sense when it comes to these requirements. So a simple user experience that inspires secure use. That's very important for whatever you're trying to build to replace passwords, because passwords do not inspire secure use. They actually help you or make it very easy to misuse them on different services. Resistant against common attacks. We talked about guessing, brute force attacks, phishing attacks, and so on. And then easily portable across different devices. That's an important requirement as well. And to be honest, most current mechanisms do not support any of these things. Most current mechanisms, even multi-factor authentication, are still subject to phishing attacks or SIM swapping attacks or whatever. So TOTP codes, which everybody here is using undoubtedly, are not secure against these attacks. So they're good and they're definitely better than just having a password, but they don't solve many of these critical security problems. So they're not really future-proof when it comes to security. And that's where a mechanism comes into play that has been around for decades actually, that hasn't been used that often, and that mechanism is called key-based authentication. And with key-based authentication, what you're really going to do as a service is trying to prove that the user possesses a private key. So it's based on public-private key cryptography, and it basically means that the service has a public key and there's a corresponding private key, and that private key is only known to the user. So whenever the user wants to authenticate, instead of asking them to prove a secret, like send a password over to the service which we can verify, we're going to ask the user to sign something with a private key. That's essentially what we're trying to do here. So in this setup, in this scenario, we have an application running on the backend, that web application, which is trying to authenticate the user. So it's going to ask the user to sign a challenge. Or well, the user here would be involved, the client-side application, the browser, maybe some software running on the client-side system, but we're going to make an abstraction of that for this image here. And the user, or the device of the user, the mobile app maybe, is going to sign something with a private key and submit that signature back to the service, which will verify that signature with a public key. And if everything checks out, that basically means that the user has proven possession of that private key. And that mechanism is what we use for authentication. Because that private key is supposed to be private, as in, if you are the user, you're the only one supposed to have that key. And if you can sign something with the key, then we assume that you are the legitimate user. And there are corner cases where this may not be entirely true, but when it comes to authentication, we have to make an abstraction of that. Like the corner case of somebody hitting you with a stick until you pass out, and then they use your private key to sign something. I mean, that's not something we want to cover off with authentication. There's like bodyguards for that, not a web security technology that can solve that. All right, and behind the scenes, what goes on with digital signatures, which is what we're using in this mechanism, and this is important because passkeys rely on this as well, is that the user has a private key. We provide some data to sign, which is well defined in the world of passkeys, and that data to sign is basically a signature that will be submitted to the backend service. And that signature is essentially what will be verified. So the backend service has the same data that needs to be signed, that challenge that we saw in the image before, that challenge, the signature and the public key that should be the user's or correspond to the user, and it will tell you whether that is valid or not with a true or false result, an exception, no exception, an error, no error, something like that. If it's true, if it's green, that means that the signature was valid. It means that the signature must have been created with a private key corresponding to this public key, and we consider this to be valid, which means in this case that the user has proven possession of that private key and is authenticated. If it's red, then something is wrong, maybe the wrong key, the wrong user, the wrong challenge, a replay attack. We don't really care why it's wrong. We just kick it out and off we go. No authentication, invalid signature. That's key-based authentication. All right, I have the same in words if you want to review this on the slides. So basically what we have here is that we have public-private keys. The private key stays private. The public key can be publicly known, as in you can send it to a server, store it in a database. It doesn't matter because it's only used to verify signatures. All right, key-based authentication does not rely on shared secrets. So it's not a password, it's not something you send over the wire, it's not something you can reuse across applications because you don't share that private key anywhere. It stays private. And that's very, very important, and that's a very significant security property in key-based authentication systems. And if you've been around for a while, you probably recognize this system as nothing new under the sun. Key-based authentication has existed for a long time in things like mTLS. With TLS, the security protocol, you basically use this mechanism to verify the identity of the server, but you can also use mutual TLS, mTLS, where you verify both the identity of the client and the server. And that acts as a form of key-based client authentication. Mobile apps implement something similar. So a mobile app can easily implement key-based authentication as well through code. In that case, the key is stored on a mobile phone, and the app signs something to prove possession of that key. That would also be a key-based authentication mechanism. And then finally, there's the Web Authentication API that supports key-based authentication, and that's going to be one of the building blocks for Passkeys. Before we dive into Passkeys, let's look at mTLS, just to establish the concept, not really to dive into the dirty details of the underlying protocol. But mTLS is actually a very useful way to implement key-based authentication, just not for users, but for services. And what happens with mTLS is that you have, where's my highlighter? You have the user, or the browser in this case, with a private key, and they have the public key of the server, and the server has their own private key, and they have the public key of the user. And whenever you set up a TLS connection, you use a library for that, or the browser will do this for you. It will negotiate a handshake, which includes signatures and so on and so on. But if that story concludes, if everybody's happy with that exchange, then you have a secure communication channel with mutually established identities, the client and the server, with confidentiality and integrity. And this is a really, really awesome mechanism for service-to-service communication. Right? It's really awesome if you have code on both ends where you control certificates and are able to set up a connection, but when you do it in a browser with users, it looks like this. In a browser with users, you get this confusing pop-up. And that confusing pop-up is going to be like, hey, I found some certificates, like, what do you want to do? Which one is the right one to use? Like, oh, crap. And these certificates are linked to users. For example, in your EID, a Belgian EID has one of these certificates embedded on the card. And you can, if you figure out how to install the middleware and attach the card to the computer and so on, which is a mess, trust me. But once you get that working for once, then you basically can use this certificate to authenticate to a service. And it would involve your identity. The service would be able to establish, like, hey, your Belgian government name is this and that and so on. And that's a way to establish that identity through mTLS. However, it's very, very unusable. As in, one of the requirements was a usable mechanism, so people can actually use this in practice day in, day out on various devices. Trust me, it does not work with your Belgian identity card, and I don't think that any service relies on that anymore today. I haven't seen it in action since a long time. So challenges here. Usability is the main challenge. Managing certificates is also difficult, but usability, like getting users to understand how this works, to use this in practice, is an absolute nightmare. It doesn't work. It's great for service-to-service authentication, machine-to-machine. If you use a service mesh like Istio, where you have like services calling each other in a microservice architecture, it uses mTLS out of the box to secure these connections. All of that is mTLS, and that is configured automatically, managed automatically, and it's a perfect way to secure these interactions. Really rock-solid mechanism. User-based interactions, absolutely horrible and not suited for anything authentication-wise. All right. Which brings us, and you can guess where this is going, right? This brings us to Passkeys. And Passkeys, you can see it's a beautiful image from Apple somewhere. Passkeys offers something very similar, key-based authentication, but in a usable way, in a well-integrated way. And actually, what Passkeys are doing is something that has existed for a long time, but there are a few minor pieces missing. And these minor pieces have been added when Apple and Google and Microsoft jumped on board and said, like, you know what? Let's make this happen. And they all implemented the necessary support in their ecosystems to handle Passkeys, to use a passkey on a phone, on a mobile, on a laptop, on the operating system, and so on in the browsers. And because of that support, Passkeys are actually very, very usable. And the whole idea of Passkeys is to make them as usable as possible while offering very strong security properties and making authentication to web applications simple, feasible, and straightforward. All right. I don't gain anything by promoting Passkeys, by the way. It's just a very good mechanism, and I truly believe that this will have a major impact. So I'm not trying to sell you something, don't worry about that. All right, so what I want to do next is I want to talk about Passkeys, first of all, from a user's perspective. I want to talk about Passkeys to explain how you as a user can take advantage of this new mechanism and what it means to authenticate with a Passkey. And to do that, let's dive a bit into how Passkeys fit into the application. So the ultimate goal is that we're trying to authenticate to this service, this backend application, to something that needs to know who we are as a user. And of course, as a user, we don't interact with services directly, we interact with the browser. And when we interact through a browser, that browser is basically going to exchange messages to client-side application, JavaScript code and HTML running in the browser is going to exchange messages to the service back and forth. And then the browser is also the one talking to an authenticator. And the authenticator is a device managing the keys. That's where the private key will be stored and where signatures will be created. And that authentication mechanism, or the interaction between the browser and the authenticator, that's using the CTAP protocol, CTAP2. Client to authenticator protocol. If you're ever dealing with Passkeys as a user or as a developer, CTAP is something that is completely hidden from you. As a developer, you'll be dealing with browser-based APIs. This all happens behind the scenes, but if you ever use Passkeys as a user, when you want to log into a website and you want to use your phone as the authenticator, what happens behind the scenes is that CTAP protocol, just so you know how it fits in. If you ever read something about that, if you want to know how these interactions work between the browser and the phone, that's where the dirty details are. We're not going to talk about that stuff here in this session, but that's the dirty details of that authenticator-based communication. All right. In the browser, we use the Web Authentication API. And the Web Authentication API is a JavaScript-based API that will show the necessary user dialogues to make the user use a passkey and so on and so on. And that's how things fit together. That authenticator can be your phone, can be your laptop. Like I have a MacBook with Touch ID. I can use that Touch ID as a way to access my private keys on the device. I can use a USB security key. If you have a security key, you can plug it in and use that one to generate a key pair and sign something. So there's a whole bunch of different options you can use as the authenticator. The specifications are purposely vague about what it is to allow the flexibility to have multiple types of implementations. And then finally, the interactions between the browser and the service here, those are pretty much undefined. As in, there's no specification determining what messages to exchange, what data that goes back and forth. That's mostly implementation details left to libraries and frameworks that support Passkeys, just so you know how that plays a role. All right. Let's look at how we set up a passkey. Let's look at how, as a user, we can go to a service and create a new account with passkeys for authentication. So no passwords, but passkeys. So what basically happens is that we indicate to the application that we want to register a new account, right? We provide an email address, for example. The application is going to look at it like, oh, I don't know who Philippe@seccupdev.org is, so I'm going to ask the user to create a new account. And to create a new account, we need some data to pass to the authenticator, and that data is going to be a user ID, typically a user name and a display name as well, and a challenge that needs to be signed. All right, so we get that information from the backend service, and then the browser, the developer, the code here calls the Web Authentication API, and the browser will call the authenticator to indicate that it needs to create a new credential. And the authenticator will interact with the user. We'll ask the user some questions like, how do you want to handle this? Do you want to scan your finger on your fingerprint scanner, or Face ID, or a PIN code, or password, whatever? Well, password to unlock the authenticator, not to authenticate. But at that point, the authenticator creates a new key pair, public-private key, and it uses the private key to sign a challenge. And it responds back. This is browser, so we call the code called API in the browser. This is all happening behind the scenes. It calls back to the browser. It gives a response to the browser saying, like, here is the public key of the key pair I just created. Here's the signature of the challenge and some other metadata that's going to be present there. And the browser forwards that, or the application in the browser forwards that to the backend, where the backend will verify that data, make sure everything checks out, and then stores that credential, that public key, with the user's account. So we create a new user on the backend, we store the credential there so we can use it in the future. That's the experience of creating a passkey. All right? Let's take a look at passkeys in action. So I have a demo. I did not build a demo myself, but there's great showcases of passkeys out there. I'm going to use passkeys.io for this demo because it's very convenient to illustrate how that works in practice. So let's take a look at what that means. So here's the website, passkeys.io, where you can, it explains what passkeys are. They also have some images with interactions and so on, but I'm mainly interested in their feature of showing passkeys in action. So I'm going to sign up with Philippe at secappdev.org, and I'm going to move forward here. No account exists, makes sense. So do I want to create a new account? Like, yes, absolutely. So let's sign up. And like I said, there's a prompt to create a passkey. This prompt will pop up the necessary browser interaction dialogues and so on. So create a passkey. There we go, create a passkey. And you can now see that my computer is asking like, hey, do you want to set up a passkey for Philippe at secappdev.org to sign in to this application? And of course, I want to do that. That's kind of the point of the demo. There's also a button here, Other Options. And if you click Other Options, you actually have the ability to select other authenticators. So by default, Apple, this is Safari on an Apple device. So of course, Apple is going to be like, hey, use the Apple ecosystem. That's awesome. But if you want to, if you have an Android phone, you can also choose here to use your Android phone as the authenticator. Or if you have a YubiKey with passkey support, you can now plug it in and say like, no, I want to use my USB security key and so on. So as a user, you have some options. But of course, in the Apple world, you're going to use the Apple ecosystem. So let's stick with that. And let's continue our Apple commercial here. So, I scanned my finger, and we've now created a passkey. That's it. All of that stuff, the finger scan was basically me authenticating to the authenticator, saying like, yes, I'm the user, and it will create a new key pair behind the scenes and submit the public key to this application to store from my account. So I have now created a passkey on this application. That's the whole process. All right. As you can see, the user experience is pretty smooth. Other browsers support this as well. I've shown Safari here. If you would do the same in Chrome, you would get a Chrome-specific pop-up. So it's not going to be the Apple-styled pop-up. It's going to be a Chrome-styled pop-up asking you to create a passkey either through your operating system in Chrome or with an external phone or something like that. It's basically the similar concept as we talked about earlier. Brings us to the next step. We've set up an account with a passkey. So how do we use the passkey? So what happens when we use a passkey? Well, the same story actually. We talk to the service and we are basically loading the main page. The service is going to generate a challenge for user authentication, something we have to sign, and it's going to invoke or send a response that invokes the necessary APIs. So behind the scenes, JavaScript code will call the Web Authentication API, will initialize this whole process, and it will pop up a dialog to the user to select the passkey. Right? The user will be prompted like, hey, do you want to sign into this website with the passkey for Philippe at secappdev.org? And I'm going to be like, hell yeah, of course, that makes sense. And it's going to send that challenge to the authenticator to sign. So the authenticator has to use the private key to sign something. That's the browser behind the scenes. And the authenticator will ask for confirmation from the user typically, and then sign a challenge with the private key. The signature goes back to the browser, where it comes out of the JavaScript API call, the response here, and that response is being sent to the server, where the server uses the public key stored for the user account to verify that signature. Right? And that brings us to the image we saw before with the outcome green or red. This is essentially going on here. The server is going to use the public key, verify the signature, make sure it checks out, and if it checks out, then the user has proven that they possess that private key belonging to the public key, and we can consider them to be authenticated. And I have a demo of that, of course. Would be very boring otherwise, so let's see this in action. Not that there's much action here, but you can see the smooth user experience at least. So let's sign out, and let's click the button Sign in with a passkey. And you can see here that the browser is popping up this dialog. It's found a passkey. Passkeys are discoverable, so it found a passkey for passkeys.io. And it's asking me, the email address is stored with the passkey as well. So it's saying like, hey, this passkey is for Philippe at secappdev.org. Do you want to use that one to log in? And there's a scan here, a fingerprint scan. That's just to unlock the key. That's a user verification feature. That means if you come here and push me aside and you want to log in with the passkey, you can't do that because your fingerprint is not going to scan. Of course, it doesn't stop you from beating me unconscious and then scanning my finger. But again, that's not an attack we're trying to cover here. That's out of scope for this mechanism. So if I do this, I scan my fingerprint, it's now checked in, and the challenge is being signed, the signature is being submitted to the server along with the ID of the credential. Server will look it up like, oh, this credential, yeah, that was associated with Philippe at secappdev.org, and I'm now logged in to my account, as you can see right here. That's how you use passkeys for authentication. All right, and again, if you do this in a different browser, the UI will be slightly different, but the mechanism is exactly the same. There's going to be a challenge, a signature, communication back and forth to make this happen. All right. Brings us to an important question. What are the security properties of passkey-based authentication? Does a passkey meet our requirements? The requirements we listed up front? Well, actually, if you look at the details behind passkeys, I think they do. Surprisingly, well, not really, but I prepared the story a bit. So they actually do meet the requirements here. So let's take a look at what we have. First of all, authentication can be cross-platform. I mentioned this, you can use a phone as an authenticator. In that case, the passkey would be stored on my phone, and if I go to a different machine, I can go there and use my same phone as the authenticator. That would be perfectly possible, and that makes it portable. You can also use the USB security key to store passkeys. In that case, you just take the key with you, plug it in somewhere else, log in, and the passkey just works. So portability is covered with passkeys. There's even a synchronization feature for software-based authenticators, but I'll talk about that in a second. User experience is generally smooth. To be honest, I think there's probably some ways we can even further enhance the experience, especially for some very common use cases. But for now, I think it's a very good user experience, especially for technical users. This is perfectly fine to use in practice. All right. Password managers also have support for passkeys. You can also store your passkeys in an iCloud keychain, for example, if you're doing Apple, or in the Google Password Manager if you're using Android. And that means that they can be synced across devices as well. So if you have a phone and a tablet and a laptop and so on, the same passkey can be available on all of these devices, which is a very good feature because, again, it improves portability and makes it easy to use passkeys in practice. All right. What about security? Well, guessing attacks, this is key-based authentication. Guessing attacks and brute force attacks are generally out of the question. That's not a viable attack vector for key-based authentication, but phishing still is. However, because of the way things work behind the scenes, and we'll talk about those details later, but the way these things work behind the scenes is that the browser includes the origin of the page requesting the authentication. So this means that whenever you're trying to do this, the browser is going to include the name of the website or the domain name of the website and some other information, which makes it hard to abuse this with phishing, or impossible actually. Because if your phishing URL looks closely to the one you're trying to be faking, it's not going to be the same, and the browser will see the difference. The browser is not a human. The browser doesn't get fooled by a 0 looking like an O or something like that. The browser will be like, no, that's not the same, go away. And that's the phishing protection built into the interactions into the protocol. And we'll come back to that later when we look at the developer side of things. To convince you that passkeys are really awesome, let's try and take a look. This is still a live demo, so things might blow up. We'll see about that in a few minutes. But let's see if we can demonstrate passkeys in action. I also have my phone hooked up to my laptop, so let's see if I can show you the ability to use the same passkey there to authenticate as well, with the emphasis on try. So here's the phone. Let's see if yes, we can actually see something. That's good. So here's the website, passkeys.io. I have not created a passkey on my phone before, so I did not fake the setup. All I did here was create it on my device, as you saw me do live, so there's no cheating going on here. And if I sign in with a passkey here, then you will see that the phone already has a passkey for philippe@secablev.org, and it asks me to use that passkey to sign in. That's because the key that I created on my laptop was actually stored in the iCloud keychain. So Apple is keeping track of the passkeys for my account, and I can easily access them across my Apple devices. So if I continue and scan my face, then you can see that we are now logged in to our account, just like we did on the laptop earlier in Safari. So this is the same passkey that we have been, of course I can't click this because it's on my phone, but it's the same passkey as I've been using before. So I can actually open that here. That's the passkey that we've been using and was created just now earlier. All right, that's that experience. And password managers are offering something similar. So if you would be using, let's see if we can try that. It's not sure if this will work, but let's see if, this is Brave, by the way, completely different browser. Let's see if we try to sign up with a different account. Let's sign up with my other email address. Of course, live demo, so let's see if we can get the code to confirm this. This is just to avoid abuse on that service, so nothing to do about the demo. So if we create a new passkey here, then, okay, so the password manager here is not catching it, but in this case, you can create a new passkey in Brave as well. You see the user experience in Brave. But some password managers, like Bitwarden and 1Password, they have integration for passkeys. So if you hook them up into your extension, browser extension, they can create passkeys in the password manager and then use in-device sync or cross-device sync as well. For some reason, it's not picking up in the demo, and I'm not exactly sure why. But you can see here is one of the keys in Bitwarden. I'm not sure why it's not showing up here, but that's essentially the idea of passkeys. Something had to fail with a live demo. That's always the case. It's I do this on purpose to show that it's live. No, that's not true. I wish this would work, but it's sometimes a bit fickle. All right, passkeys, fairly new. And one of the challenges with new technologies is like, yeah, but who supports passkeys? Well, the good news is everybody. Passkeys are universally supported across major browsers. So Chrome, Edge, Safari, Opera, Firefox, they all have passkey support, which is no surprise for Chrome and Edge and Opera because they're all Chromium based. So once Chromium has it, they all have it. But Firefox has implemented this and Safari has implemented this. This is like an industry-wide supported mechanism for user authentication. A lot of people believe in this, and that's why I believe that this has an actual chance of succeeding, because support is universal. All your users will be able to use passkeys. Well, unless they're on something like, I don't know, even Samsung browsers have passkey support. So really, it's very, very widely supported. And no IE does not count. That's not a browser, so forget about that. All right. That's the user. Let's put on our developer hat. Let's talk about the dirty details of passkeys. How do you implement passkey support in a web application? So that's essentially the next topic, and there's a lot to say about that. There's a lot of nasty details that you might want to know about when you're dealing with passkeys. So let's start with the beginning, creating a passkey. Like I mentioned, this uses the Web Authentication API. Web Authentication meaning that there's a credentials whatever API in the browser, like the Web Authentication API, and it supports a create and a get methods. Create is to create a new credential, get is to use a credential. All right, so we're going to talk about creates first. It supports different types of operations, and for passkeys specifically, we're going to use public key based operations. Of course, that's relating to the public-private key pair that's going to be generated behind the scenes. All right, so simple, right? Super easy. I mean, how hard can that be? Just create with some options and you're good to go. Well, actually, the create part is actually fairly complicated because the options on line 2, I've made them an abstraction for a reason. They're very complicated. So the options, here's the full picture. The options take like a lot of detailed configuration to configure them for your specific use case. But don't worry, I'm going to walk through all of these one by one to explain what all of the options mean. So let's start with the RP. Whenever you're doing authentication, the RP is a relying party. That's basically the client asking for the user authentication. And in this case, clients, it's a web application. It's a web application use case. So the ID is referring to the relying party using the part of the domain name. So in this case, it's restaurant.com. That's my training application I use for training purposes. It's about restaurant reviews, which is totally irrelevant for this use case. But restaurant.com here supports passkey-based authentication. All right, so what do we provide there? We provide an ID. That's what the browser will actually use to establish the actual identity of this relying party. And then there's a name, which is a human readable name of that relying party. The ID here, the identifier is linked to the actual URL of where the application is running. And that's how the browser can provide things like phishing protection, because the browser forces you to use an ID that is part of your domain name. It can either be the full domain, app.restaurant.com, or it can be one level higher, restaurant.com. Nothing else. You can't use like funnycatpictures.com as the relying party ID because the browser will tell you no. You'll get an error message if you try to do so, and the browser will basically tell you like, haha, nice try, but no. All right, that's part one. Part two is the user object. In the user object, we provide information about who the user is. So this is when you create an account, so the user has provided their email address, maybe their name, and you can include these parameters in the request to create the passkey. And because you can include them, that's how the phone OS or the browser can show you like, hey, this passkey is for philippe@seccupdev.org. That's because it's included in the metadata of that passkey. So here, the name is going to be, the username is the email address, which makes sense for a lot of applications. And then the display name is a human readable name for that user. Users also have an ID, an identifier. The ID for the user is also known as the user handle. And it's recommended that it's not something that contains personal identifiable information. So it shouldn't be an email address or a name or something like that. It should be a random ID. And it's also preferred that the random ID is not linked to the primary ID in the application. So it shouldn't be the user ID column in your database or something. It should be a separate user handle. So you can create some level of abstraction. So if something changes on the user ID part, that it doesn't automatically mean that your passkey identifiers break and so on and so on. So that's to basically decouple the passkey stuff from the user identifier stuff in the application. All right, so just a random identifier for a user. All you need it for later is to look up a specific user in a database. So you would basically be like select star from users where user handle is this random identifier, and it doesn't matter what specifically the value is there, as long as it's something that you can manage. All right. See, it's not that complicated once you understand what's in here. So it's just a matter of knowing these things, and then the options start to make sense. That's why I don't have like a huge list of PowerPoint notes of what everything means, because once you understand this, it actually does make sense. The challenge. What's the challenge? Well, that's a thing that has to be signed with the private key. In the registration phase, this is used to ensure that the user actually has that private key for setting up this new passkey. Mostly a safety check to ensure everything makes sense. So this challenge is random data provided by the server. So yeah, there's not much to tell about that. It has to be there, and that's it. That brings us to the authenticator selection. That one is actually a bit complicated. The authenticator selection is where you as a developer have the opportunity to tell the browser, and by extension the authenticator, what type of credential you would like to create. And there's a very important property here, and that's called resident key. And resident key means that we're telling the browser that a credential that we're trying to create has to be discoverable. Meaning that if the browser is asking later to the authenticator, like, hey, do you have a passkey for restograde.com? There's a way for the authenticator to say like, yeah, of course I do. That's what that means, discoverable. So that the browser can show you that list later, like, hey, here's some passkeys you have available, which one do you want to use? That's the resident key property. For passkeys, this is required. This is mandatory. That's the whole concept of a passkey. This also means that you don't have to provide a list of valid keys up front. So the service doesn't have to tell the browser like, hey, I want the user to authenticate with one of these keys. No, we'll see that in a second, but we just tell the browser like, yeah, man, go find me a key for me to authenticate the user. That's basically what we tell to the browser. All right, awesome. Apart from this, there's some other properties as well. You can provide an authenticator attachment property. And the authenticator attachment can be cross-platform or platform. And that's basically a way for you to say what type of authenticator is acceptable. Platform means something built into the device that the user is using. Like the Touch ID on a MacBook or Windows Hello on a Windows laptop, that would basically be platform specific, as it's baked into the device. You can't port that away from other devices. Cross-platform is something portable. A phone would be a cross-platform identifier, a authenticator. A USB security key, I'm pointing to my pocket here because I actually have one on my keychain, but a USB security key would be a portable cross-platform authenticator as well. So you can specify that during the creation phase. There's also a property called user verification. And user verification can have different values, and that one basically allows you to tell the authenticator whether the user must be authenticated during the use of the key or not. So for example, when you saw me using passkeys before, you saw me scan my fingerprint, that's user verification. We ask the user to authenticate so that we are certain that this particular user is present. You can also just ask for user presence, like is some meat-based life form present, basically. Doesn't really care which user. You don't have to scan a fingerprint, but you typically have to touch a button or do some interaction so that somebody knows that it's not malware doing things, but an actual user. But they don't check which user it is. And you can, of course, turn this off as well. For passkeys, User verification is highly recommended. To set this to required, but preferred is also possible. It depends a bit, all right? And authenticators can interpret this in a way they want. For example, a password manager may decide that if you're logged into the password manager, the user verification requirement is fulfilled because you logged into it once, and as long as the session is active, it's considered to be valid. So that's definitely true. Or you can have it like every time, as you saw with the demo before, where I had to scan my fingerprint every time I use this, or use Face ID for that purpose on my phone. And then the resident key property, here we have covered that in the previous slide, so I don't need to elaborate on that again. Awesome. When I said dirty details, I meant that, by the way, so my apologies for diving so deep into this API. One more and then we're through. One more property and then we have covered them all, basically. Pub key cred params. All right, what the hell does that mean? This is basically which algorithms can be used to generate signatures. And this is closely linked to what the backend supports. So this signature has to be verified on the server at some point in time. So whatever the server supports, you can configure this here as well as a viable option to use. And these are self-explanatory, right? So I don't have to go into detail about the meaning of -7 and -257. Of course, everybody knows what that, no, that's not true. Nobody knows what that means. Well, that's not entirely true either. We actually know what these mean because there's a list of algorithms, so a very long list of supported algorithms with their numbers like -7 and -257 and so on. And the whole problem is knowing which algorithm is useful, but you have to map that algorithm to authenticators as well. Because if you select an algorithm that Apple doesn't support, then you can't use Touch ID, which may not be desirable in your specific use case. So people are actually asking the questions like, yeah, the algorithms are fine and the identifiers are maybe not usable, but we can map them, sure. But what does that mean for using Touch ID? What does that mean for Windows Hello? What does that mean for YubiKeys? And it turns out that nobody really knows. Well, actually somebody did some research, somebody tried this all out, all the different configurations to see what works and what doesn't work, and apparently, which is literally apparently, like, yeah, it seems to be that -7 works for most of it except for Windows Hello. And for Windows Hello, you need -257, like, okay, yeah, sure. And YubiKeys are the ones that support -8. It's like, oh yeah, okay, good, useful information. Thank you, GitHub comments on this particular issue. Long story short, you'll need to look into this. However, consensus seems to be if you use -7 and -257, you'll support most of the use cases out there. This seems to be a viable configuration that you'll find in most Passkey deployments these days. But of course, your mileage may vary. It's very important that you link this to, where's my highlighter, to your backend. Because selecting something here, but you can't verify the signature on the backend, that would make it very useless because then everything would break down after you created a passkey, which is not recommended behavior either. So yeah, this is a nasty one, but we kind of figured out how this works or should be used in practice. All right. What is the result? These were the options for credentials.create, right? We call this JavaScript API, we provide these options, and then the browser does its magic. The browser will provide some additional metadata, send the data forward to the authenticator, which will pop up the dialog, Touch ID, create, blah, blah, blah. And the result of all of that magic behind the scenes is an attestation response, an authenticator attestation response, which is a well-defined object. The links are here at the bottom if you want the dirty details and the dry specs. But it's an object with metadata about the newly created set of keys. Attestation is about created credentials. We also have an assertion later on, which is about the use of credentials. But attestation is creating credentials. And in the response, you'll find a JSON object, which is very much encoded, so it's not really straight up JSON, called client data JSON. And this data is created by the browser and the authenticator, and it's provided as a response to the JavaScript code. And the idea is that the JavaScript code will take parts of this data and send that back to the backend so that the backend can verify the signature and create a new credential in the database. That's essentially what you're supposed to do. That's the part that's unspecified anywhere that you kind of have to figure out a bit how to handle that in practice. All right. What does the client send to the backend? Well, the specific format is dependent on whatever you're using on the backend, but concretely it's a public key because you need to store that public key for later. And it's authenticator data, a binary format, indicating some flags and properties of the authenticator that has been used. And you can use these to either accept or reject the authenticator data for some reason. All right. Let's explore this in a bit more detail. It's something less dry than slides. I'm going to use a different website this time, learnpasskeys.io, because somebody else has done all the heavy lifting of implementing this step by step, and I just get the easy job of walking through it and showing what's going on. So let's go here. Let's do this in Chrome. Why not? Learn Passkeys.io. Oh, that was not intentional. It's a Passkeys playground. It's available online, so you can do this on your own as well. And what we're going to do is we're going to create a new passkey, and I'm going to show you all the different steps, and they actually show you the data as well, instead of just doing some magic and hiding everything from the user. So this is for developers, not for users. So let's create a new account. They don't allow you to choose your own usernames to avoid you from messing with the system. So they just give you a fictional username. So from now on, I'm known as Catlin, not Philippe, but Catlin. So just assume that name for me, and we should be good to go. So we're going to create the options for registration. So you can see that step here. That's before we call the API. And the registration options, you may recognize this. Let me make this a bit bigger. Here you may recognize this as we have the challenge in there. We talked about all of these in the slide, right? We have the RP information. We have the user information here with the name, my name, Catlin, of course. We have the -7 and the -257, as I explained, and so on and so on. And you can see here that we require a resident key, and user verification for this particular demo is set to preferred. You could also set this to required, but in this case, they have chosen to use preferred. All right. Next step, use this. This should pop up the browser dialog and ask us to create a new passkey. So that's the next step here. Is called the create method. So we have selected our options, and if we click the button now, the create method will be called with these options, and that will pop up the browser's dialog, the Chrome experience here, asking us to create a passkey. I'll create it in my Chrome profile because that's less effort to clean up after the demo, so let me just do it like that. And the browser is now asking, like, do you want to create a passkey for learnpasskeys.io? Here's your information, and so on and so on. And I'm like, yes, please, let's do that. User verification was set to preferred. So you can see here that Chrome is actually hooking into the fingerprint mechanism from macOS to ask my presence here. So I'm going to do that as well. And off we go. Here's the response. That's the attestation response. Remember, attestation was about a creation of a new credential. So that's the dirty details. And I'm going to highlight some interesting parts. There's an identifier here. And the identifier, or the raw ID, is basically the unique identifier for this specific credential. And that will come back later when the user uses one to authenticate. That ID will be there as well. And that's how you can look it up in the database, like, oh yeah, this credential, oh, that was for Caitlin, awesome. And of course, Caitlin is from that point on authenticated. There's also information like, hey, we used the -7 algorithm. Here's a signature. And a bit lower, there's going to be the public key somewhere. Here's the public key. So that's basically the key that my authenticator, in this case Chrome, has generated. And that's the public version of the public part of it. The private part is inside my Chrome on my device. It's not shared anywhere. It's not accessible. You can't extract it and so on. Here are some of the flags. These are binary flags encoded into the data. You can see whether user was verified during the creation, like yes, we did, because I scanned my fingerprint. That's why it's on true. The user was present as well, user presence versus verification, and so on. You can also see whether it's a backupable passkey or not, in case it's something you rely on, and so forth and so forth. And then finally, you can also see that the origin of the application is embedded right there in the data. This tells the backend where this passkey was created. So the backend would get this data, and it says, like, this was created on funnycatpictures.com. You could be like, huh, I don't think I want to accept that passkey. No, thank you. So in this case, we're learnpasskeys.io. The backend expects something from learnpasskeys.io. That's very, very important to prevent somebody from trying to tamper with your application. All right, that's how you create passkeys. Let's continue the flow here, and everything's sent to the server. We can see the public key, blah, blah. We're done. I needed to do this because in the next demo, we're going to use the passkey to log in, and I'll show you the dirty details of that as well. All right. If you're getting depressed by now, it's like, oh crap, why did I come to this talk? All the dirty details and all the configuration options, I'm so done. Don't worry, we've done the hard part. Creating the passkey is the heavy lifting. From now on, it's like easy sailing for user authentication. Things get a lot easier. Because what do we have to do? We call the get method now. Credentials.get. And you're probably getting like PTSD from, oh no, there's an options here in line 2. Crap, what is the options going to be? Don't worry. Well, I have some things to get through here, but don't worry, the options are very simple. That's it. We have a public key-based authentication. We used this relying party ID before, retrograde.com, and we provide a challenge that needs to be signed. And that's it. The browser will do everything else. We call this, and the browser's like, awesome, I know what to do now. The browser will take that RP ID, will look for discoverable credentials. We'll be like, hey, I found like 3 passkeys, one in your iCloud keychain, one in your Chrome profile, maybe one on your phone. Which one do you want to use? You click it, the authenticator signs something, and all the magic happens, and the user is authenticated. That's essentially it. This RP ID is crucial. That's built-in protection against misuse. And it also helps against phishing protection, because this is something that is validated by the browser. The browser enforces this. If you try to provide a value that's not part of your origin, your URL, the browser will reject this request. That means if you try to be sneaky and you're like, I'm not resto-grade, but I'm rest0-grade, which is almost the same, but not really, but the browser will simply be like, no, let's not do that. And that's why phishing doesn't work anymore. Because a phishing page trying to pretend to be retrograde, but not really retrograde, will not be able to use a key from retrograde, and that's why it will simply fail. Really important built-in mechanism, and not something you have to implement, something that the browser does for you, because it's part of the protocol. All right, and then the challenge is something that needs to be signed, has to be random and unique and only used once, and so on, because that's essentially how we prevent certain attacks against this authentication flow. All right. When we've done this, we get a response out of that API call. So we call credentials.get, we get a response, and that response is an assertion. And it contains, again, a whole bunch of information about the credential being used and the signature and so on. And the client, it's a bunch of array buffers, so it's a nightmare to handle in JavaScript because it's like low-level stuff and messy. But once you know how to handle that, what you get out of it is the credential ID. Remember, the thing that was created during creation, we can now get the same ID back, so we know which key was or credential was used. We get, again, a client data JSON, like an encoded JSON object, and a bunch of authenticator information. And of course, a signature. And the client doesn't handle any of this. The client, the JavaScript code running in the browser, doesn't do anything with this except take the data and send the relevant parts, or all of it, depends on the implementation on the backend, sends all of it to the backend, and the backend is responsible for verifying this. And again, I can show you how this works in practice so you can see these details in action. All right, use a passkey to log in. Seriously, these demos are super awesome because this would have taken me a week to implement myself. So generate the authentication options. That's the simple options for step number 2. Why generate? Because we have to create a challenge to sign in practice. So you can see here, there's a challenge that needs to be signed. And there's, again, an option to have user verification to preferred. You could set this to required if needed, but in this case it's preferred. And the RP ID is right here, learnpasskeys.io. Note that we don't tell the browser up front which keys are valid. We just tell the browser, go find some keys, please. So let's see what happens if we use this. Sign in with a passkey. Chrome is popping up its dialog like, hey, I found a passkey for this, for Caitlin, something, and you stored it in your Chrome profile. Do you want to use that one? It's like, yeah, I do. Thank you. Fingerprint scan. And here is the result. An assertion now, not an attestation, but an assertion. The ID is here again, so that ID allows the backend to find this credential on their end, find the public key, because there's no public key here. There is just the identifier, which allows the backend to retrieve the right public key. There's a signature right there. The user handle, like this identifier for users, is also included here in the data. And then, of course, we have the client data JSON here as well. Note that the origin is still there. The backend is still required to verify that origin to make sure it matches its own application, to make sure that there's no attacks here. And that's essentially what we do. And this is submitted to the server, verified, and so on and so on. Finish login. Awesome. And that's how Caitlin authenticates to learnpasskeys.io. Good. One more time, because the difference is really important. It seems like a stupid detail, but it's something that you can easily get confused. Attestations are about creating a new credential, the metadata there, and assertions are about an authentication. So you do the attestation once, and then you have the assertions for every future authentication proving the use of that credential. And that's how passkeys work. This is not the end though. I still have a bit more content to cover. One important aspect of the success of passkeys, or the potential success of passkeys, is a smooth user experience. Especially when maybe some users still have passwords and some users may have passkeys, and like showing buttons, and guess what, a user doesn't remember whether they used a password last time or a passkey, and it's going to be a mess. And that's why browsers today support an additional feature called Conditional Mediation, which is a very complicated word for saying like, there's an option that you as a developer can tell the browser, if you have a passkey, maybe suggest the use of that passkey to the user, and if you don't have a passkey, then maybe shut up about passkeys and just ask for the username and maybe a password. That's basically what this is about. And it's an autofill feature on a form and a JavaScript API. Well, a JavaScript option. So let me show you the autocomplete feature. So on a form, there's an input field for a username, and you can set autocomplete to WebAuthn. And WebAuthn here means that if the browser has passkeys, that they are allowed to show a pop-up on this input field saying like, hey, maybe you want to use your passkey for authenticating here. That's what this means. The second part here is called conditional mediation. And conditional mediation is basically the idea that if there's a passkey, the browser should suggest the use of that passkey. But if there is no passkey, then the browser maybe should not show like this big pop-up saying like, oh, I didn't find any passkeys for this website, and so on and so on. So that's essentially that part here. And conditional mediation is an option that you can use when you create credentials. Credentials.get, mediation conditional on line 6. This tells the browser, like, if you have passkeys, by all means go for it. But if there's no passkeys known for this website, just leave it as it is. Don't show an error message to the user, don't prompt the user, just leave it as it is. That's what this means in practice. And I can show you that in action as well. Of course, that's pretty straightforward to illustrate. But it really adds to the user experience, and it's a really cool feature. Let me show you that on on Passkeys.io. Conditional mediation is basically this, right? Imagine that there's just an email field with a sign in button or a continue button, no sign in with a passkey because you don't need that button anymore. If you click here, well, I've screwed it up now. If you click here, conditional mediation says like to the browser, if you have a passkey, why don't you suggest this to the user? So the user comes here to the application, it's like, oh yeah, I apparently used the passkey last time. I forgot about that, but sure, yeah, I want to use that one. Click, and you can use your passkey, and bam, you're logged in. And if there's no pop-up, and you may have a username from last time, you can type like philippe@seconddev.org, and then it's going to be like, hey, what's your password? So you can choose between, or you can have the same login flow for users with a password and with a passkey, and that is going to be a very important mechanism to have like upgradability towards the future. And this mechanism is a separate mechanism than the whole web authentication API. It's a specific UI element, or UX element if you want to call it that, and there's separate support for that, but again, everybody supports this. Like everybody is on board with the passkey ecosystem, and that's really, really awesome. All right, what about the server? What about the backend? Well, I don't care about the backend too much. What about the backend? Well, the backend has a whole bunch of responsibilities, but to be honest, you probably don't want to be implementing all of that stuff yourself, like signature verification and getting all of the binary data out of these flags, and it's an absolute mess. It's very complicated code. So what I'm going to do here is I'm not going to explain to you how to implement that. First of all, it would take us like a few hours to get through that. But I'm going to explain the responsibilities, like what should a backend do, and then I'll point you to some libraries that you can use that do that for you. Libraries handle the heavy lifting. You typically don't have to touch these low-level data exchanges. So the responsibilities of the backend, there's no way, or the specification does not define how to send the data from the front end to the backend. It's just like, yeah, here's your response from the JavaScript API, figure out how to get it there. In reality, it means that whatever server-side framework you use, you will send the information that they need. So some frameworks, they use the full attestation response or the full assertion response from the browser. So you send it in full over there, it's fine. Others want specific fields, so you can send specific fields. It's basically going to be up to that. What do you have to do? Well, during registration, you have to provide the browser with a user handle, like this ID for a specific user, and the challenge to sign. That's the responsibility of the backend. The browser will do the whole web passkey generation thing, and then it sends the data to the server, and that data, the server has to ensure that the origin in the data matches the expected origin. All right? The server also has to ensure that the feature flags are what you expect them to be. Like if you want user verification, then make sure that user verification is true. If you don't need it, then you don't have to check it. If you want a cross-platform key, then check that cross-platform is true. Otherwise, you can leave it fine. But you have to check what you want to be enforced here. And then additional metadata, you can verify that as well. You store the data and the public key somewhere in the database, and that's part one. Part two is when the user authenticates. During authentication, you have to generate the challenge again because something has to be signed. So the backend is responsible for generating the challenge and then handle the incoming data. In this case, handling the incoming data means looking up the authenticator with the ID of the authenticator, using the public key to verify the signature and make sure everything is correct. You can again verify the metadata provided by the in the response as well to make sure that this corresponds to what you expect to happen there. That's essentially what you're supposed to be doing during authentication. Now, where can you find libraries to implement that? Well, Passkeys.dev has a page with libraries of actual implementations that are vetted, that you can rely on, that implement Passkeys fully. And one of the implementations here is for Java, built by Yubico. Yubico is this company with strong authentication mechanisms, has been around for a long time, and they've been doing FIDO implementations of USB security keys, and it relies on the same mechanism. So they also have a passkey implementation, which makes perfect sense. And there's a JavaScript version as well, simple WebAuthn. It's widely used for JavaScript-based passkey implementation, so it's also a pretty solid library, but there's alternatives for different languages as well. All right? And even if you would have to build something yourself or augment an existing implementation with support, you can use these libraries as inspiration for how to do that in practice. All right. That's essentially how you authenticate with passkeys. Authentication data has a unique ID. That's how you find the right credential in the database. That's essentially whatever links things together. And all of this relies on two core building blocks in the browser, the Web Authentication API and Conditional Mediation. These two building blocks together were actually the final missing pieces of the puzzle to make passkeys a potential success. That's essentially what's going on right here. All right. One more topic, one more thing to cover, and that is how you fit all of this into an existing application. So what are the final pieces of the puzzle that you can rely on here, and how can you drive passkey adoption? So first thing, to adopt passkeys, it's not going to be a revolution. It's not going to be the case where this is going to be a revolution that will eliminate passwords today and switch to passkeys right now. They're going to coexist, right? Eventually, what you'll have is you'll have a lot of people using passwords, and then some people will start using passkeys, and gradually can evolve your user database across your applications. So that's definitely how this is going to go. If you implement it that way, I suggest you allow people to turn off password-based authentication. Because to be honest, many implementations today, they offer passkey support, which is awesome, but they don't allow you to disable your password, meaning that the weak link of your account is still your password because it's still going to be there. So allow people to say like, hey, I want to be passkey only, no more passwords. That would be one option to do that in practice. Keep in mind when you're implementing this that a user ideally has multiple passkeys. So this is something that a lot of people don't know, and I only discovered this by talking to one of the people that helped implement passkeys at Microsoft. And the idea behind passkeys is actually that you have one portable passkey, for example, a phone or a USB security key, and you use that to sign into the application. And then the application detects like, hey, this sign-in was with a cross-platform, a portable authenticator, and it suggests to user like, hey man, what if you create a passkey on your local device as well? because then next time you come to the application, instead of using my phone and, using the phone and doing something with the phone, I can just be like, oh yeah, scan my fingerprint and I should be good to go. So if I can do that, then this would be a very useful user experience, and I can have multiple passkeys. I can even have like 6 or 7, depending on how many devices and how many authentications I need. So that would be the user experience here, and that's something that requires application support. This is not something you can automatically do in the browser. This is something that the application has to detect and prompt the user to suggest them to use this pattern. So that's kind of the vision, which is not very well documented, to be honest, and something that you might want to take into account. All right. Of course, adding multiple passkeys is straightforward because you're looking them up by ID anyway, so it doesn't matter whether the user has like 4 or 5 passkeys. You just find one with the ID, and you should be good to go. All right. Keep in mind, passkeys are typically linked to the origin, right? We had the RP ID in there, but also the browser includes the origin. And the RP ID is typically the domain of the application running, the host name. If I'm running this on, let's use example.com, on login.example.com, right? Then chances are that you will link your passkeys to login.example.com, which is, it makes perfect sense. Why not? However, one of the drawbacks is that if your boss decides, like, you know what, login sounds like, it's not cool. What if we use accounts.example.com instead? Because we want to be nicer and friendlier, and we want to deploy our authentication service on accounts.example.com. If you do that, but all your passkeys are associated with the RP ID login.example.com, they will stop working because you've changed the RP ID and the browser doesn't allow login or accounts.example.com to use login.example.com. That's simply not allowed, and the browser will give an error message and all your passkeys become invalid, and your users will be very, very unhappy and blame Passkeys for that. So there's a potential solution here, not a potential, an actual solution. And the solution is that you're allowed to use a higher level domain as the RP ID. So on login.example.com, you are allowed to use example.com as the RP ID. And that gives you flexibility. By using example.com, you are now more flexible, and you can actually use the same passkeys on login.example.com and on accounts.example.com. which gives you that flexibility. Now, is this a major thing? No. It's definitely not an intentional feature of sharing passkeys across subdomains. Please don't do that. That's absolutely not intentional. But it does allow you the flexibility to redeploy services on different subdomains if you need that. So if you think that might be a useful feature, this is very useful to know. Otherwise, you don't have to care about this at all, and you can forget about what I said just now. All right? And then finally, whenever you use passkeys, try not to implement passkeys in every application you use. This is pretty complex stuff. You really don't want every application to have their own database of passkeys. If you have multiple applications, you should be relying on a central identity provider to handle authentication, right? And that's something you do with OpenID Connect. With OpenID Connect, that's the de facto standard for doing this these days. With OpenID Connect, instead of authenticating to the service, instead of going here for authentication, the user will go here for authentication. It's a pretty complicated setup. I'm not going to talk about the dirty details of OpenID Connect, which would take me like half an hour to explain the flow. But in general, it means that the user will go to the service and say like, hey, I want to log in. And the service is like, oh, not here, please. Go to the central identity provider, to our login system, running on accounts.example.com, for example. And the user will go there and authenticate to the rest of the application here. They will be asked to log in with a username, no, with a passkey, of course. That's what we're talking about here. Not username and password, but passkey. So users will use their passkey here to authenticate, after which the user's identity is confirmed. There's a confirmation of authentication, which is then sent back to the service on top in step 7, and that's how the service knows who the authenticated user is. But the authentication happened here. That's centralizing authentication with OpenID Connect. That's the current industry best practice. And this allows you to have like multiple applications. If you have like a calendar application, a mail application, and maybe a document application, they can all use the same identity provider with the same passkey here for authentication. And that's a best practice. And if you already have a setup like this, if you already use OpenID Connect, then implementing passkeys can be as easy as flipping a switch. Because if you're using a service like, for example, Auth0, Auth0 has implemented Passkey support, and many other identity providers have already implemented Passkey support, allowing you to toggle the switch like, yes, I want the users to allow or to use passkeys, and you now have Passkey support. It can be that simple, and they have implemented all the dirty details and handle all the signature verification and the storage and so on and so on. But of course, the implementation details may be different. Some of them may allow you to disable passwords, some of them may not, and that depends a bit on what they're doing exactly. And that brings us to the conclusion of the Passkey story. So, 3 important key takeaways. First of all, Passkeys offer key-based authentication with a great user experience, better than anything we had before. And I think a very big part of that is the vendors like Microsoft and Google and Apple, their ecosystems joining the effort and making sure that this works across devices. That's really important. Passkeys are widely adopted by browsers, password managers. There is an immense level of support, and that makes it really valuable as well. Now finally, when you're deploying or building applications, consider to use Passkeys, to offer Passkeys as a good alternative. They're really good. And when you do so, also give users the option to turn off less secure methods like password-based authentication. All right, that concludes the story about Passkeys. Thank you very much for being here. If you need help with security, reach out, and I'm more than happy to help with that. And that's the story of Passkeys. Thank you. And now you can ask questions. Yes?
I don't remember the context exactly, but at some point I think you said something along the lines of the server should verify the RPID or the origin of the responses that it gets. Can you explain that a bit more? Because I don't see how that cannot easily be spoofed.
Yes, that's a fair question. The best way I can explain that is by going into our example here. Well, I think that's the best way. Let's see if I'm right. Here's the assertion response, and the origin is right here. You would think that this data is spoofable, but the data itself is also part of the signature. So the signature is not just a challenge, but it also includes the data generated by the authenticator. Otherwise, the JavaScript could just be like, haha, I'm going to change this value to that, and oh, the user ID is actually this ID. So no, that's not possible. So the data that is created by the authenticator is also part of the signature, or is also considered to be signed. So there's integrity protection, and you can't just change things after the fact. So that's definitely what plays a role there.
Okay,
thank you. All right. Yeah.
Thanks for the talk. It was really interesting hearing how we can create passkeys, consume the passkeys across the platforms, etc. But there is also another topic behind the scenes that a lot of criticism gets been heard. That about the life cycle of management operations of passkeys themselves. So how can I recover access to passkeys in case they are stored in kind of keychain or whatever that I don't control, etc. How much secure is this particular?
Yes. Let's just ignore the elephant in the room, right? Or put our head in the sand. Recovery remains a problem. You're absolutely right. I did not talk about recovery at all. First of all, passkeys are revocable. So if you go to an application or the demos I just showed, there is a list of passkeys. I can go into the application and I can delete this passkey. Like bam, done. So that passkey is no longer valid for my specific account. So that's one part of the story. So let's say that somebody steals your phone. You can go into your accounts and remove that phone-based passkey as valid and handle it that way. Recovering is a bit different. So let's say that I lose access to the passkey that for some reason no longer works, and I want to recover my account. There's no answer to that. As in, that is always a problem with authentication systems. Very often recovery is just like an email with a code to reset your account, and then your email is the weakest link at that point. So that's a bit of an issue. However, that's part of the vision of passkeys. If you follow that vision of having this one portable passkey and then local passkeys on every device, then you always kind of have your own recovery. Because let's say that my portable passkey or my laptop gets stolen, I can use my portable passkey to log in and remove the other passkey from my account. And if my phone gets stolen, I can use my local passkey to remove my phone and set up a new phone. So that kind of plays into that vision as well. But you're absolutely right that there's no defined recovery mechanism. So maybe something to work on and get working in practice, yeah. Any other questions?
So, if when Microsoft is using like passwordless authentication, is what is being used in the back? Is that Passkeys what is being used in the back with passwordless?
I don't. To be honest, I don't know what Microsoft is doing with passwordless authentication. Do you have more details? Like,
well, I know that Microsoft introduced, like, I don't know how long it was ago that they introduced like passwordless.
is it with the mobile app or?
With the authenticator, yeah, so that you get an authentication
Okay.
request from your
Yes. No. Then I know what you're talking about. Even though I've never used it. The mechanism behind the scenes is key-based authentication, right? Except that what they're doing is, because they're Microsoft, they're big enough to convince you to install their specific app, and then they can send a push notification to the app. So in the backend, you tell them, like, I want to log in with Philippe at secopdev.org. They look up that account. They're like, oh yeah, we have this app installation linked with that account. And they send a push notification to the app, typically with a challenge, and the app signs something with a key on the phone and sends that back, and that's how you can prove possession of that key. So it's basically like a similar mechanism that is the same conceptual idea, except for the fact that it only works because Microsoft is Microsoft. As in, if you're like Restograde, my training application, which is a website with restaurant reviews, there's no way you can convince people to install a mobile app for handling passwordless authentication. And that's what Passkeys bring to the table here. So behind the scenes, the idea is the same, and you'll find a bunch of these other apps that follow the similar pattern, but it only works if you're big enough to actually make that work for your users and not if you're a small website. So Passkeys work for everyone. It's like the socialist version of key-based authentication. Do not put that on a recording, please. Yeah.
Maybe kind of a follow-up question on the big enough thing. Are you aware of any big websites that already implement this in practice?
Yes, a lot actually. Like identity providers like Auth0 actually do have Passkey support. Google has Passkey support. GitHub has Passkey support. Like a lot of websites have jumped on board. So absolutely, go look for it and you'll find it. I would say that most people who have done the effort to implement multi-factor auth with keys like YubiKeys or WebAuthn, for them the lifting to Passkeys was like very minimal because they already had everything in place. So yeah, you'll find plenty of support for that. Start using it today, absolutely. All right, thank you very much. I hope you enjoyed it.